So after looking at the what is a transformation, Laplace transformation, after looking to the formulas, now let's solve a differential equation using the Laplace transform. Okay, let's do a little example. Derivative of y respect to the time plus 5y equal to 0 with the initial condition of 1, for example, right? Very easy, actually you can solve it. It's a variable separable differential equation. If you do this to the other side, derivative of y respect to the time equal to minus 5y, and then you separate the variables, differential y over y equal to minus 5 differential of t, and you take integrals. Okay, so what you get here is the natural lorem of y equal to minus 5t plus the constant, and then you apply exponential on both sides, so y is equal to the exponential minus 5t plus the constant, that is equal to the exponential of minus 5t times exponential of the constant. The exponential of a constant is still another constant, so y of t, the solution is just the constant exponential minus 5t. So that is the solution using the common method, the previous method, where you have the solution now. Usually, because we have an initial condition, we have to calculate the constant at the end. However, in the Laplace transform, the initial conditions should be given at the beginning. And let's see why, engineers. Now, we are going to solve the same problem, but using the Laplace transform. So, as I said before, we are going to throw this differential equation into the Laplace transform tortillas machine. Okay, so it's going to be the Laplace transform of derivative of y respect to the time plus 5 the Laplace transform of y equal to the Laplace transform of 0. The Laplace transform of 0 is still 0. Okay? The Laplace transform of the derivative, if we use the formula that we have seen, is going to be s capital Y, y of s, minus y of 0. In the formulas is f of 0, but because this is y, it is going to be y of 0 plus 5, the Laplace transform of y, small letters, is going to be capital Y. Okay. There is very confusion for the students in to say, what is the Laplace transform of y? We leave it at capital Y. Why it is like that? Because we don't know what is the value of y. Y is actually the solution, is what we are looking for. Because we don't know, we leave it like that. Alright? So in the tortillas machine, y of t, if you pass it through the tortillas machine of the Laplace transform, it's going to be capital Y of s. Alright? So, but we don't know what is y of t, because that is the solution, what we are looking for, so we don't know what is y of s. So we leave it like that. Now, here's the beauty, engineers. Here we have derivatives, but here in the s domain, this is the t domain, but here in the s domain, you don't have derivatives. So this is just an algebraic problem where you can solve it very easy. Now, y of 0, what is the value of y of 0? Is equal to 1. Okay? So you are given the initial condition from the beginning. So in the problems of the Laplace transform, the problem has to tell you what is the initial conditions. Otherwise, you cannot solve it because you will have here a variable. Alright? Okay, now, this is an algebraic problem where you can factorize the y, is the same. So it's going to be s plus 5 times capital Y, and this minus 1 equal to 0. Now, we can do the factorization because there is no derivative. You cannot do that here, you cannot factorize the y because this is the y and here is the derivative. But in the s domain, you don't have derivatives, so we can solve it very easy. Okay, now let's clear the value of capital Y. Capital Y is going to be equal to, this to the other side is plus 1, and this passes a division as s plus 5. Alright? Now, as I said before, the problem is that this solution is in the s domain. and we don't need the solution in the another dimension. We need the solution in this dimension, which is the y of t. So to find y of t, what we are going to do is apply the Laplace inverse, capital Y of s. So applying the Laplace inverse of this is applying the Laplace inverse of 1 over s plus 5. Alright? Now, to find that Laplace inverse, we are going to use this formula. The Laplace inverse of 1 over s minus a is equal to the exponential of at. Okay, so in this case, remember, positive is going to be negative. If this is negative, here is positive. Now, if it is positive here, in the exponential is going to be negative. So y of t happens to be the Laplace inverse of this. Here is plus 5, then it's going to be exponential minus 5t, which is the same solution that we solved before, exponential minus 5t. Now, why we don't have the constant here? Well, we do have the constant, it's here. It's just that in the previous problems, you have to calculate the constant at the end. But the constant is given at the beginning, so you already have the solution now. This is how are we going to solve differential equations. Alright, but this is a very easy problem, first order differential equation. Next week we are going to see higher order differential equations, and we are going to see more formulas to solve this kind of differential equation, because the difficulty here is the Laplace inverse. Making the Laplace transform is very easy. Factorizing, getting the y of s is very easy. The problem is going to be the Laplace inverse. Alright? Okay, so see you next video.